What's the best compression algorithm for Spark? Is it easy? Is it LZO, Snappy?
It's that is and has always been it depends type of situation. It depends on your type of data. And what's your trade-off for CPU versus? I mean, there's always a trade-off between CPU and size there.
But are there any gotchas with like splittability or anything like that? Was that we have to worry about?
Okay, so
Go ahead.
Snappy and gzip are not splittable, but if you put them with any format in Hadoop, they're splittable. So that's a non-concern, right? So in general, Snappy uses the least amount of CPU, but it sucks at compression, right? It gets, in anybody who tells you that you can get a certain number of compression is lying to you, but in general, it's about 2 to 3 times. I've seen it be worse, I've seen it be better, right? So, and then gzip is about 8 on average. You know, it can be worse, it can be worse or better, but it normally takes about 40% more time to compress something in gzip. Now, reading speeds is, both of these are going to be way faster than reading text, right? But in certain data formats, just like you said, gzip will outperform Snappy on reads. So it's not Spark or not Spark. This is just like raw entropy and compression and stuff like that. And then there's bzip2, and bzip2 will probably get you maybe to 10 or 12 or something like that. But bzip2 is like the slowest dog on the planet. And then there's LZO, and LZO is like Snappy.
And there's always there are all these gotchas that have historically been there with each of the different formats. Like for instance, Snappy had a situation at one point. Actually, I don't know if this is fixed yet because I'm a data scientist, not an architect. But there was some weird memory consumption issues for a period of time there. So just be aware. It's sort of a you try it out kind of situation.
But the other big thing you need to consider is block or columnar file types. That's really huge. Because to get the splittability with a block, they take, I think it's 100K for a sequence file. They take 100K and compress it. And whatever the entropy is in that 100K block, that's going to be your compression, right? So sort order really will determine your overall compression rate for your file. But columnar file types like RC file, Parquet, or org files, they compress in blocks but in columns. So it's the entropy of the column itself. And normally a column is more like itself than the other columns in the row. So you get lower entropy, which means you get higher compression rates. And also, if you decide to only read a portion of the number of columns, you only have to decompress the portion that you care about.
And one thing I would add, before you even consider compression in terms of which algorithm to use the natural compression that types give you, right? Storing an integer as a string versus storing an integer as an int. That a lot of people just don't think about that, but it's like before you even start, you should have your type set up.